Hey, it's Chris from Space Weather Watch, and wow, has it been an absolutely incredible week in terms of space weather activity. What you're looking at here is the NOAA Space Weather Prediction Center's homepage, and on the left side there, the GOES X-ray flux, you can see we've had two major flares, solar flares, over the last 48 hours or so, including an X 7.1 class flare and an X 9.0 class flare. So let's dive right in, take a look at them. This is the Solar Dynamics Observatory imagery, and this was the first flare here. This is an active region that has become increasingly aggressive and violent over the last 48 hours. This is active region 3842, very magnetically complex, and so this first solar flare was an X 7.1 class flare very late in the day on the 1st of October as we entered the new month. And then things had been fairly quiet here. You notice a couple of shifting frames with the calibration. And then today, this incredible X 9.0 class flare, which is the most intense solar flare since 2017. And not only that, but the largest solar flare of this current solar cycle. So, and certainly the largest flare that I've ever worked since I have started my space weather career. So, incredible stuff here. We are tracking a couple of different coronal mass ejections as a result of these solar flares. One of them here was associated with this X 7.1 class flare. What you're looking at here on the right side is the SOHO-LASCO instrument. It's a coronagraph which blocks out the sun using what is called an occulting disk and allows you to see the outer portion of the solar corona. So this fainter portion is where we're actually observing solar storms or coronal mass ejections. And so you can see here this CME, we refer to them as CMEs. This CME is seen to the south and to the east and is associated with this flare. This CME ended up actually measuring to be a little bit slower than we might originally sort of expect for a very powerful solar flare like this. There isn't really a clear association between solar flare intensity and the velocity of coronal mass ejections, but it's not a very clear relationship. But in general, these more powerful solar flares generally have stronger CMEs. Not always, though. And this is a case where this CME was a bit slower than we were sort of anticipating. So it is going to take a few days to get to us, this CME. We'll show this. Let's show the simulation for it here. This is the CME scoreboard, which is a website that shows predictions from the space weather research community. And is available through the CCMC, or Community Coordinated Modeling Center portion of NASA. So what I'm going to show here is the simulation, and I'll run through this pretty fast. This is the simulation for this CME that I had just shown, and you can see it's a little, there's kind of a lot going on if you're not familiar with the way these simulations look. But essentially, this white circle here in the very middle is the sun, and the Earth is this yellow sort of circle off to the side. This left-hand image here is a top-down view of the solar system. So you're looking sort of as if you were standing sort of on top of the sun, looking down at the solar system. So this coronal mass ejection does appear to hit Earth, and will probably do so in the late October 4th into maybe early on October 5th. Probably it's going to end up on arriving in the second half of October 4th. And these are the arrival times from the community on the left-hand side where my mouse currently is. And you can see that the average is around about the 17 Zulu or UTC time on the 4th. So that's kind of when we're generally expecting the CME to arrive, although there is a bit of uncertainty across the space weather community right now. And then we also had, in addition to that CME and flare, we had this incredible X 9.0 class flare. This is one of the most impressive events I think I've ever seen during my space weather career. We're still sort of waiting for imagery to kind of trickle in here. This was the early frames of this particular CME, and there should be some more up-to-date imagery now. Yeah, so This is it's a very complex looking CME, as you can see, and it's mainly, I think this portion off to the left or the east side is actually a different event altogether, I believe. However, this portion to the south is undoubtedly associated with this solar flare. And so this coronal mass ejection is likely to be faster. We're still analyzing it at this point, and when I say we, I mean the space weather research community. The NOAA Space Weather Prediction Center folks are responsible for putting out the official forecast for this event. So we'll wait to see how this event shapes up. The space weather community uses a bunch of tools to measure these CMEs and understand how fast they are going, as well as their trajectory through the heliosphere. So an incredible, sort of beautiful event here. This one is probably going to be faster and could potentially arrive in the same sort of time frame around the 4th or 5th of October. So if this particular CME were to catch up to the first one that we had showed earlier, we could potentially be in for some very, very interesting geomagnetic storm effects, maybe a much stronger storm. So the anticipation in terms of the intensity for these events is the first one is a KP range between 4 and 6. So that is considered, the 6 is considered a moderate geomagnetic storm. So it is on a scale of 9, 9 being an extreme geomagnetic storm. So certainly we could be seeing values that are higher than 6 in the coming days if we do, and we're likely to see impacts from the second CME, this one here, which is associated with this more Earth-directed and more Earth-facing solar flare and coronal mass ejection. So we'll have to see how things shape up, but certainly it's been a very, very interesting week, and I'm excited to be able to talk to you about it.